Hey guys, so we're going to do a lesson today on scale factor. And you might remember scale factor we did in the classroom. We talked about Legos, right? And how Legos are scale factor images of some real life object, right? We also talked about the movie Zoolander, how crazy weird this guy was because he didn't realize that, like, you were dealing with a model, not an actual center for children. And this example here of a car, right? Looking at what's the relationship in the measurements between the new model of the car and the old model of the car. All right, so getting into how do we actually find lengths using a scale drawing? So a scale drawing is either an enlarged, right, or reduced drawing of an object, but it's still proportional, meaning you can use a proportion to help you figure it out. So the way we set up our proportion is drawing over actual is equal to drawing over actual. And the way we taught it in class was for you to put the scale over on that left-hand side, and they will tell you what the scale is. Once we have our proportion, we can cross multiply, divide, and figure out our answer. So let's look at an example. So we have an example here of scaling on a map, right? So you'll notice it tells you outright that the map scale is 1.5 inches is equal to 60 miles. So that's your scale. That's why it's written over on that left-hand side of your proportion. What you also notice is it says, okay, the distance on the map is 7.5 inches. Well, if inches is on the top of your proportion on your left-hand side, it must be in the top of your proportion on the right-hand side. So that's why that 7.5 is over on the right-hand side. Then we put that over our variable because our variable represents miles. How many miles in real life? We cross multiply, divide, and find out that the distance is 300 miles. So let's work out an example because I know sometimes it's easier if we work through it. So on this one, a scale drawing of a park is 4.5 inches long, right? That's how big the park is on this little drawing. The scale is 0.5 inches is equal to 10 feet. So maybe this is like the architect drawing up the park, or maybe it is the civil engineer who is working on this. And we want to know, what is the actual length of the park going to be? So the first thing we need to do is set up our proportion. Okay, so we have our drawing over our actual equal to drawing over actual. You'll notice that I put the scale on the left-hand side, and then on the right-hand side, I made sure that if I had 0.5 inches is to 10 feet, then on the right-hand side, it's inches over what will be feet, because the actual length is going to be in feet. So after we have this set up, we can then cross multiply. We can set up our little palm tree, right? For those of us, or use our butterfly method, whatever. So we cross multiply. We end up with 0.5 times x is 0.5x. 4.5 times 10 is 45. How do we eliminate that 0.5 that's stuck to the x? Remember, we call that our coefficient. Well, I divide. So I divide both sides by 0.5 in order to isolate my variable. And I end up with x is equal to 90 feet. So what does that mean for our problem? Well, it means that the actual length of the park is 90 feet. Okay, and you can always rewind these if you need to. All right, next one. So we can also use scale factors to solve area problems. And the biggest issue I see kids have is they're like, oh, cool, it's a rectangle. I know that the area of a rectangle is length times width, and they just want to run and multiply things without really knowing what the steps are. So the main thing we need to remember is that if you're dealing with a scale factor problem and you want to find area, you have to do the scale factor first. So we have this drawing, right? Maybe this is a building manager, right? Or maybe this is an architect. Maybe this is just a person who wants to build a deck on their house. And they drew it out, right? Maybe they went to Home Depot and got this done. They need to convert those centimeters to yards before they can figure out the area to figure out how much wood they need to buy for their deck. So let's see how that's going to work, right? So the first thing I notice with this is we might not have to use a proportion. This is actually a nice scale. Dude, check it out. Our scale is 1 to 2. For every 1, it's 2. So that would mean if 1 centimeter is 2 yards, 2 centimeters would be 4 yards. 3 centimeters would be 6 yards. See where I'm going with this? It's just this times 2. So I really don't even need to use a proportion for this. You could if you wanted to, right? But I'm a fan of working smarter and more efficiently. So I look at this and I say, hey, all I got to do is take the centimeters, times them by 2, and change to yards. So let's take a look. Well, I know that my width over here was 8 centimeters. Well, 8 times 2 is 16. I know that my length was 16 centimeters. 16 times 2 is 32. So what does that mean? That means that my actual width is 16 yards and my actual length is going to be 32 yards. Like when I actually build this deck, those are what the measurements are going to be. All right. So now I can use that information to help me find the area of what the real deck's going to be. Because now I have an actual width and an actual length. I know that my area formula for area of a rectangle is length times width. So now I use my length and my width, right? My 32 and my 16. My 16 and my 32. I multiply them and I end up with the area of my deck is going to be 512 yards. That means I'm going to need to buy 512 yards worth of wood if I want to make that deck properly. Okay, so I hope that this video helped with scale factor. Please let me know if you have any other questions as you're doing the activities that are assigned with us. And I love you so much. Mwah! I'll talk to you later. Bye, guys.